So our proof of concept works in the following manner. The Raspberry Pi will be taking images at an interval of time and sending it to our cloud server. On the server, we have already preloaded the program called YOLO, which processes the image and calculates the traffic density at that particular junction. The server then sends that information back to the traffic light, and then accordingly we change the signal sequence using the script which is running in the Raspberry Pi. Also, the data is parallelly sent to our web page server, where we can, through Google Maps, we show the exact location of the traffic junction, and at the same time we're able to see the live images, and if any kind of abnormality rises in the traffic, that appears as a pop-up on the web page. So now we will be demoing what we have done. So for the sake of this PoC, we have already established the connection to our PoC cloud server, and now we will be running the entire algorithm and the whole sequence of operations through the server script. So right now the software is loading up, and it's already calculated it for the first image, and it's just basically what it's doing here is just initializing the libraries and running the matrix algorithms on the images, and as you can see, it's doing it pretty effectively and fast. So now it's done doing it for all the 4 images, and it's calculating the traffic densities. The traffic densities is now being sent to our web page, and after sending it to along with sending it to the web page, it also sends it back to the Pi. And at the Pi controls the traffic signals to accordingly change the signal. And all the images which are currently being sent are the processed images. So now we'll be showing the updated images on the web page. As you can see, the one which is red indicates that there's a heavy traffic congestion, and that's what I was stating before when I meant the pop-up. So if we click on that particular junction, we're able to see the various images at that particular junction. For now, these are all dummy images which were already previously loaded into the Pi. With real traffic cam data, the traffic cams will be able to display their images over here. Now, this website will not be available to the public. It is meant for municipal authorities to in the particular jurisdiction, so that they can monitor the traffic and also send rescue and alert systems at any point of time if any abnormality rises. Okay, thank you. I will now be talking about the practical test which we had conducted at the Ithamadu traffic junction on October 21st around 6 p.m. This junction has a signal time of 120 seconds. That is, to complete one cycle of operations, it takes 120 seconds. Now, as you can see from the image, there were 3 cameras placed, and these cameras were oriented towards the roads in such a way that they would be in frame of the ongoing traffic. So these cameras would simultaneously take pictures and send it to the cloud server. The cloud server would then calculate the density of vehicles in the image, and along with that give a prediction of what kind of vehicles were present in the image. So we had used that prediction in our signal timing algorithm. In this algorithm, we had decided to divide the vehicles into 3 subcategories. Category 1 contained 4 and 3 wheelers, like cars and autos respectively. Category 2 contained two-wheelers, and Category 3 contained heavy motor vehicles like buses and trucks. Now for each category we had assigned a different time wait. And in this case, for Category 1 we had allocated 5 seconds, Category 2 3 seconds, and Category 3 10 seconds. We arrived at those numerical values of weights based on the amount of time, on average, the particular category of vehicle was taking to cross the junction. So after conducting this experiment for 4 different cycles, we arrived at this data set. Now from this data set, it is clearly seen that the amount of time spent overall for all 3 roads is less than the 120 seconds which is there in the present model of that traffic junction, thus showing that our model has a lesser time interval for changing the entire signal sequence and thus reducing the amount of time the vehicle spends at the traffic junction.